Good morning. It is a gray day. We got our robot working. Pushes all the buttons on the keyboard. So we wanted to... The original robot software, if you could call it that, was a pretty heavy hack. It only worked on the older systems. So at the pointy end of the robot, you know, the mechanical side is basically a solenoid. You know, one solenoid per piston, and the piston fires and pushes the buttons on the keyboard. So all that was custom. Wow. But that was IBM. I mean, you know. So the idea was to grab those solenoids and figure out how to run them off some separate boards. And you know, there's 105 or 150, yeah, 105 or 120, I guess it's 123 possibly, up to 123 pistons for some of these robot positions. And some of these robots had gone down over the years, so it made a lot of sense to design a card that could be interfaced with to fire these pistons at 24 volts. So my boss and I have been kind of working on this project for a while, off and on, and figured out run it with I2C, drive it with a Raspberry Pi, and read the input as a standard, you know, USB HID device on the Raspberry Pi itself. So it's a little circular, but I think it's a good way of handling it. That way you don't have to communicate between two different devices, and you get full USB like hosting, acting. I mean, it would be very easy to test this electronically to see that when you press the button that, you know, the logic card reads it, and then it asserts that that was correct, that the button that was pressed was correct. But that's not really a test where the rubber meets the road. You know, you want to be... I'm using a lot of euphemisms here. So, or idioms. The rubber meets the road. That's like, you want to test the keyboard on an actual computer system and see that the computer reads it as a USB device and that it receives all of the key inputs that come out of it, all the scan codes that come out of it. If you test that electronically before it actually registers as a USB device, then you're not really testing it, you know, essentially. You could be testing it mechanically, but you're not testing the whole system of the keyboard. Earlier I said the the tip of the spear. Tip of the spear is where the actual work is done. You know, the physical work, really. So the pistons are, or the solenoids are what fire the pistons. And deciding when the solenoid needs to be fired and unfired, or powered and unpowered, is a job for a brain. You know, something with some level of logic and intelligence is going to decide when the solenoid fires. The solenoid is not intelligent. So we're basically just kind of swapping the brains out, or the control mechanism, or the logic out of the robots. So, we have a card designed that will interface with all those pistons, has, you know, 32 IO on it, so that it can fire those pistons at 12 volts while running at 5 volts and accepting, I think it runs at, maybe it runs at 5, maybe it runs at 3, accepting a 3.3 volt I2C interface. So it runs some Darlington pair thingies that fire off the 12 volts, or the 24 volts, and kick off the solenoids. So we have that. That's that's all tested out now. And we got the Raspberry Pi part working pretty well. So now I'm working on kind of the timing issues because there's, you can read all keyboard output of the, or rather all keyboard input, I guess, of the keyboard device by running key read and in an actual terminal, not a pseudo terminal. So if you run key read in an actual terminal, you'll get not scan codes, but key codes. So it is post driver. So the scan codes are going to the keyboard driver, and the keyboard driver is generating key codes. And those key codes are being forwarded along to the OS. So it's probably at the right layer for that. It's just kind of a pain to work with. But there really isn't another way to catch things like modifier keys, because the modifier key is essentially unprocessed until you press another key. Now, it's not essentially unprocessed. For most systems, it's essentially unprocessed. That's a good point. Maybe there is a better way to do that. Oh, okay, that's right. Yeah. So essentially, all of this had more to do with Python. Raspberry Pi, Python, and all that. Yeah, and all the I2C interfaces on at the Python level. Well, maybe they're different. Well, I get down on Python a bit, but it is very versatile and very easy to work with. Yeah. So the deal is, since it's Python is only listening and only catching somebody. Oh, that's not right. That can't be right. I gotta look into that more. Because there's like gaming systems, gaming libraries that Python picks up. I forget what it was. There was something. It was either the modifier keys or combinations or makes and breaks. There's something that I could not track in Python just reading it as input. Man. I'm glad I'm talking about this. I haven't thought about this for a bit. Maybe I can make a library to hook into something. Part of the problem with this, and it's kind of a problem, is the system for reading all of those key codes, called key read, is very good and very complete. But it is so complete that it entirely absorbs all of the keyboard input, to the point that you can't even interface with it afterwards. The only way to leave it is to type nothing for 10 seconds. Now, you as the user inputting that information, yeah, you can't leave it without typing something for 10 seconds. But programmatically, I can write the system or set up the script so that it detects when it's complete, and then it grabs the process ID of key read and performs a graceful kill on it. So doing that gets me out of key read, but that's the program doing it, not me, Control C or Control D escaping out of it. And I even tried to rewrite some of the source code for key read, but I couldn't get it to compile at all for the Raspberry Pi. So maybe I need to target something a little bit more targeted there. Maybe there's a certain version or something. I don't know. This was not a lot of fun. Maybe it is easier to just rewrite the whole thing in C. Or C++, whatever. The other thing, further complicating this, is I have, you can set up USB hosts so that they interface with these devices, like hardware level USB hosts, so that you don't have the entire OS to move around within. Huh. I don't know. Yeah, but that's not very visual. Yeah, you don't have a great interface with everything. No, okay. Yeah, this is fine. This is fine. Even if it is a bit of a hack, that is one of my favorite, not memes, I guess. I don't know, joke images, image macro. I don't know, whatever. It says whenever you write some code and you think, well, this is just kind of a hack, just remember that a CPU is a rock that we tricked into thinking. And the follow-up is, well, not to diminish the accomplishment, but we did have to flatten the rock first. Yeah, that was a big realization for me when that happened. That was many years ago. I was working at a managed service provider. We did mostly monitoring, but also like I handled the patching and the pen testing and kind of security aspects. We had this monitoring system, and I was like, man, this thing's great. Man, this thing's cool. Man, this interface is awesome. But it wasn't quite fitted for us. So it had problems for our specific use case. So I was, programmer, and I got into, I love LAMP, so I set up a system. Like I was having to scraping at that point. So I'm like, why don't I just scrape this web interface, pull in the data, and process it, add my own logic on top of it. That is literally what I'm doing with the Crockpot. Unbelievable. I could just, there's some part of me that just wants to subvert things. It's very strange. Not subvert, but just like twist the logic just a little bit. Like, you come up with a system, and I'm like, this system's great, except it would be better if it was 1% different. So I'm going to write an entire new interface for it so that it's that 1% different. No, I mean, like, making middleware and stuff like that, or and people call it glue nowadays, I guess. Like, making this talk to that and connecting them, it's really hacky and it's really kludgy, but once you do it, it's like, wow, this is super useful afterwards. You connect these two systems. Yeah, it's a lot of fun too. Gosh, anyways, so yeah, I was like, oh, this is a big professional monitoring system. This is way better than the last two systems we had. This is great. And I was trying to get this system to do what we wanted it to do, and I started developing this middleware application, middleware software that would pull down the data at various layers and then do logic on it at all those layers and then represent it to us. And it had things like alerting and tracking different systems, and allowed us to add notes to it. It allowed us to silence alarms, and these are all things that were not features that were not added to the original software. And it was great, but my boss somehow managed to get one of the guys from, no, I'm not gonna say it, one of the guys from that company to come and talk to us, like a technical guy, like a legit technical guy. And I was like, hey man, yeah, I kind of got this working, here's what your product is doing for us, here's what it wasn't quite doing for us, I know we're not your standard kind of customer, so we're not going to say, drop everything and change for us, but this was our solution to it. Could you help me find out why this doesn't work with that, And it was like, oh yeah, it's easy. The whole thing's kind of a mess. And I'm like, no, this is professional grade software. You don't understand, sir. This is very expensive. And he's like, no, it's a total kludge of like 5 different applications that we hacked together. And I'm like, really? He's like, yep. I'm like, well, actually, it kind of makes sense then if that's the case. Like, that's why this layer doesn't talk to that layer, and there's like this significant delay, and sometimes things get out of sync, and like this part doesn't even know that part is broken. And he's like, yep, we're working on it. We're trying to improve it every day, but you know, it's just kind of difficult to get all the stuff to hack. I'm sure he didn't say hack, but hack all this stuff together. And he was very impressed with the work that I had done. He's like, "Oh no, this is great. Yeah, these are some great ideas. Like, how'd you do that part? How'd you do this?" Like, bro, you're the professional. I'm just farting around with some code here. He's like, "Oh, this is really good." Like, really? So that's when I started to realize, like, you get into this mode where you're like, what is it? Oh, there's a word for it nowadays. Imposter Syndrome. That's right. And I'm sure you've heard of it before. It's somewhat popular at this point. Imposter Syndrome is where you're like, I'm awesome. I'm great. You know, I know exactly what I'm doing. And then like the other 50% of the time, you're just like, I have no idea what I'm doing. No one knows that I have no idea what I'm doing. I'm just faking it until I make it. I'm an imposter. I'm not even good at what I'm doing. And I imagine it's probably more prevalent in coding, only because there's a lot of copy pasting. I wonder if imposter syndrome happens more in artists, or if because that seems like that would be like you borrow from someone else's art or their style or something like that. At least to start out. But imposter syndrome, and that was what really broke it for me, was when, you know, I didn't call it that at that point. I was just like, well, I'm not really a professional. I'm just kind of messing around with this stuff. And he was like, oh, this is really good. How'd you do this part? Oh, no. Our stuff is just a hack. Forget about it. Like, really? Like, this is a very, like, this is enterprise level. Straighten the tie. Enterprise level. And no, it's all just hacks, man. It's all just kludge. It's all just a mess. It's all just fake it till you make it. It's a little sad. Well, maybe. Maybe not. So yeah, robots. So, you know, the hack, I think I have a blog post about this. I wrote a blog post about this. Video games. It's about the kludge is perfection, I think, is what it was. Like, it's, you know, you think if the code works, the code works. You know, there isn't much space for someone to be, academic. I did work for a different company that application was that was like a master's thesis in object-oriented, well, what we currently consider object-oriented programming. There's hierarchies within hierarchies within hierarchies, like layered, ad infinitum, ad astra, stuff that didn't even exist, but like theoretically we might want to do this in the future, so let's carve out a space for it. Oh, that application was really something. It was a bit of a mess, obviously, but it was really something. And that was an enterprise application, and it was very academic, at least internally. Yeah, externally it was just kind of a kludge. Yeah, I remember that. Yeah. They would design so many different objects within the hierarchy, object types, and like I'm blanking on the word. It's different structures in the hierarchy, and then they would come up with these structures in the hierarchy that were very similar over here and similar over here, and they're like, oh, well, these are kind of similar. Like, technically this type of thing should have been constructed down this path and maybe branched off here. And then the other guys, no, this one should have been constructed in this path and branched off here. And still some other groups are like, oh, no, these two are completely different. You don't even understand. So they just built like little linkages between them. I guess that's what I mean when I say academic. It's like, practically, are we able to work with this? Like, if you make it so, you know, make it perfect, quote unquote, how complicated is it, and how easy is it to actually get work done with it? Because the point of code is to accomplish a task, is to convince a CPU to perform an activity and replicate a logic in the exact same way that you to instantiate logic into it, such that it executes that logic correctly. I don't know. It's interesting. I think I've got a good balance at this point. Maybe. Just don't be afraid of the hack. You know, don't be afraid of thinking that your code is kludge. Don't be afraid of thinking that it's a mess. Just be improving. As long as you're improving, you'll be getting better. If you can look back at your code from a year ago and say, yeah, this is good, then you're not improving. There's lots of opportunity for improvement. I'm making like I'm gonna leave. I haven't even stopped yet. All right, have a nice day and stuff.